Hey everyone, it's Actuary Dude over here. Let's have a look at another question and see how quickly we can get it done, because it's a long one. The force of interest delta t at time t is given by all over that. So calculate the present value at where time t equals 0 of an investment of £1,000 due at time t equals 10. So all we really have to do is find £1,000 that we have in 10 years time and discount it back 10 years. That's going to be v of 10. Okay, so now all we've got to do here, and this is the long bit, is find v of t. And so v of t is going to be, I guess, well, we've got to find it when t is up to 10. So let's get to it. Now the first bit, that is e to the negative integral of this bit delta t over here. And when you find the negative integral and then sub 5 and then minus 0, it's just going to be, well, sorry, not 5, we're going to sub in t. So it will actually look e to the negative 0.04 t minus 0.003 t squared, like that. And that'll be, oh sorry, that's not 3 squared, that's 3 cubed, and that's also a 1. So I'll just write that, 3 cubed on 1, because then we're going to divide everything by 3, so 0.003 divided by 3 is 0.001. That is for 0 is less than t, which is less than or equal to 5. Now in order to find the next bit, we've got to find v of 5. So we just got to sub in 5 to t. So let's use Excel for that bit over there and say, alright, that's going to be equal to negative 0.04 times 5 minus 0.001 times, well, 5 cubed is 125. And so we get negative 325, sorry. E to the negative 0.325. Okay, then the next bit, well, we've got to find e to the negative integral of that bit in between t and 5 of 0.01 plus 0.03t, which is then, well, the integral of that is 0.01t plus 0.03t squared, and that's all divided by 2. And that can then go inside there with a negative out the front between t and 5, and that's e to the power of that. So I'll just say equals, and then we'll just sub in, that's then going to become e to the, and then I'll leave the negative outside still, and say that 0.01t when we sub in t, plus 0.03t squared on 2, and now we just have to minus when we sub 5 into all of that, so I'll use Excel again, and I'm not sure the best way to do this. Here we go, that's the part, so we can just say equals I'll just say 0.01 times 5 plus, and that's 0.03 times 5 squared is 25, all divided by 2, 2, and that'll give us 0.425. So it's going to be minus 0.425 over there, 0.425, like that. And then where we can write it here is we're saying e to the negative, because I'm now multiplying everything by a negative, 0.01t minus that's a minus there, 0.03t squared all on t, and then that's going to be a plus 0.425, and we've got to multiply it by this bit over here, v of 5, so plus 0.425 minus 0.325 is then going to give us a plus 0.1, and that is for 5 is less than t, which is less than or equal to, I believe it was 8. And it said it there in the question, if I remember. Yep, there we go, that's 8. Okay, so now we just got to do that next bit, which is then e to the negative integral of this bit over here between t and 8. So I'll write that down, e to the negative integral between t and 8 of 0.02. And so that's then going to be 0.02t in between, there's a negative there, t and 8, and there's an e there. So that equals, and then that's just going to become e to the negative 0.02 plus 8 times this is going to be 0.16, and that's a t there. Okay, so that's what we're looking at, and we've also got to then multiply this by v of 8. So v of 8 is subbing 8 into this last bit over there, so let's use Excel again for that. Drag it to the other side. So in fact I can even just write down v of 5, and this is going to be v of 8. So what is that? Well, that's going to be negative 0.01 times 8 minus 0.03 times 8 squared is 64 divided by 2, and that's plus 0.1 over there. So we get negative 0.94, so negative 0.94. That's what we got. So that's then going to be e to the negative 0.94, so negative 0.94 plus 0.16, so I can just note that down, e to the negative 0.02t, and then 0.94, that's going to be 78 minus 0.78, and that is for when t is greater than 8. Okay, so that's what we've got, and now we've just got to find v of 10 and multiply it by 1,000. So 1,000 multiplied by e to the negative 0.02 times 10 minus 0.78. Let's use Excel for that again and just say, yeah, in fact, while I'm sort of following an order, I may as well do that and just say, well, actually, sorry, those aren't v of 10, that's not v of 5 and v of 8, that's the index there. So in fact, I'm just going to get rid of that. So we are just finding out now equals 1,000 multiplied by the exponential of negative 0.2, which is 0.02 times 10, minus 0.78, and that should give us 375.31 pounds. So pounds, that's 375.31. There we go, that's part I done. Part double I, let's see what we want. Calculate the constant rate of discount per annum convertible quarterly, and that's discount over there, which would lead to the same present value as that in, I think that should be, part I being obtained. So let's find, so we're just trying to find over here, what is D4 equal to? I don't know. So in order to do that, in fact, I think we should be able to hurry this one through and say that, well, I'm first going to find the effective interest rate. So what I'm going to do is say 1,000 divided by that figure that we've got. Sorry, that should be an equals there. So I'll put that in. Equals 1,000 divided by that bit. And then so to the power of 10, we're putting it to the power of 1 on 10. So that's going to give us that. And then when we minus 1, that's what the effective interest rate is. So that's what I is. So now let's find out what D is. That's equal to I divided by 1 plus I. And that's what D is equal to. And now to find out what D to the 4 is, well, we can use the formula that we've got in our nominal and effective interest rate videos, which would be P multiplied by, you open the square brackets, 1 minus, and then 1 minus D, close those brackets to the power of 1 on P. So really what that is saying we're doing 4 times 1 minus D in here to the power of 1 divided by 4, because we're doing quarters. And okay, I've done too many equals, but that's the answer. There we go. Not too many equals, too many brackets I did. So that 0.0, so that's going to be, D4, 0.0968. 0.0968. And so as a percentage, that would then be equal to 9.68% per annum, which was referring to, and that's what D4 is. If you have any trouble with that question, because I didn't show much working, then please ask, and I'll definitely just fix all that up. Okay, so part 3, calculate the present value at time t equals 0 of a continuous, payment stream payable at a rate of that from time t equals 10 to t equals 18. So this is a fairly straightforward question. We've never really had much issue with this. It's the same thing. It's the integral between 10 and 18 of this thing multiplied by v of t. So this is rho of t, and we're multiplying by v of t, and b of t when t is greater than, I guess, well, 8. So we're just going to be doing this multiplied by this and finding the integral. So let's see if I can remember that. So the present value is equal to the integral between 18 and 10 of, I think that was 100 e to the 0.01t, and then we've got to multiply that by e to the negative 0.02t, and then that was minus 0.78, like that, if I remember right. Yeah, that looks right. Yeah, that looks all good. Okay, first things first, we're going to simplify that, so I'm going to take the 100 out, still put it between 18 and 10, multiply these two together, so that's going to be e to the negative 0.01t minus 0.78, and there's a dt there, and there's a dt there. And now the integral of this, well, it's the same function, but then we're just taking the index, the derivative of the index out. So that's just negative 0.01, and I can take it out of the whole thing because it's applied to the whole function itself. And so in fact, I'll just put that in square brackets and say it's e to the negative 0.01t minus 0.78, close square brackets, between 18 and 10. And now I can just use Excel to solve that and say that the present value is equal to, in pounds, whatever it is. Let's get Excel out and solve this bit. So I'm going to say equals 100 divided by negative 0.01 multiplied by the exponential of negative 0.01 times 18 minus 0.78 minus the exponential of negative 0.01 times, that's times, I'll show you more of this, 10 minus 0.78, close both brackets, and there we have it, 318.90. 318.90, and that's the answer. So thank you so much for watching, and please ask if you have any questions.